So today we're going to talk about domain and range. Domain is, in simple terms, anything that X can be, and range is anything that Y can be. These are pretty simple concepts, but we're going to look at their application across many different areas. Here we have a graph, and we're asked the domain and range. Again, when we think of domain, we're talking about X, and so it kind of helps if we think of X as an axis down here, being from left to right. So we're kind of talking, when we talk about domain of a graph, how far left the graph goes and how far right the graph goes. So we look, the minimum this graph goes to is 2. It does include the 2, it touches 2, so I'm going to use this square bracket to say that the 2 is included. The minimum that the graph goes to is 2, and the maximum that the graph goes to is here at 8. Again, it touches, so I use a square bracket. That is, our domain is from 2 to 8. Our range is anything that Y can be, our Y-axis. We're going to start from the bottom. How far down does a graph go? How far up does a graph go? We can see this graph touches at about 5 as a minimum and goes all the way up to 40. The thing you need to remember here is when we look at the domain, we're only measuring the X. When we look at the range, we are only measuring the Y. Example 2. Here we have a table. We're given some X values and their corresponding F of X's. When we talk about the domain, here we can see we have 0, 100, 200, 300 listed as X's, but we don't really know what's happening in between. It's not safe for us to make any assumptions. So all we know about X is that it could be 0, it could be 100, it could be 200, or it could be 300. We really don't know what's going on in between. Because this is just a list of numbers or a set of numbers, we're going to use these, what I call curly Q brackets, as part of our set notation to denote that that is a set of numbers. We're not talking about from 0 to 100. We're just talking about the individual numbers 0, 100, 200, 300. Our range then is anything that Y can be, and according to the table we're given, Y could be 2,000, 3,000, 4,000, or 5,000. Again, I'm going to list these from smallest to largest. So it's important to notice this notation. These square brackets says the domain can be anything from 2 to 8, including 2 and 8. So our X could be 2, our X could be 2.1, our X could be 2.9. With our set brackets, we're saying that X can only be 0, 100, 200. There is no in between. Example 3. My babysitter charges $8 per hour plus a $10 fee for gas. She will not work more than 6 hours. When we talk about the domain here, it's important for us to know the relationship of this. My babysitter's charges are a function of time in hours. So our domain is anything X can be, and in this case, we're talking about time in hours. So how much time could the babysitter spend? Could she spend negative time? That doesn't make sense. Could she spend 0? Yeah, I'd argue that she could spend 0, so we'll include 0. In this problem, there is a real life maximum my babysitter has set herself. It says she will not work more than 6 hours. I'm assuming then she will work 6 hours, just not over 6 hours. So I have my domain. My babysitter will work anywhere from 0 to 6 hours. When I think about the range, the total price, my total charge, I have to actually do some math here. I know that the minimum charge would be if she spent no time. And then we'd say, oh, say she came to my house. I said, something's changed. I don't need you to babysit for any hours. I might still get charged this $10 fee for guests. That is, if she comes to my house to babysit, her fee is going to be at least $10. Now we're going to look at the maximum. Say she spends a maximum of 6 hours at my house. 6 hours times the $8 per hour is $48, plus the $10 cleaning gas fee, $58 total. Because she will only work 6 hours, the maximum I can get charged is $58. Example 4. Notice this graph has some arrows indicating that it does go in those directions forever. It continues. When we talk about the domain, we're talking about left and right on the x-axis. And even though this goes left very slowly and this goes right very slowly, the arrows do indicate that it goes forever. Because this goes forever left and right, our domain is negative infinity to positive infinity. However, nothing actually touches infinity, so we're going to use round parentheses here to indicate that our function goes all the way up to, but not touching that value. When we talk about the range, we're talking about the y up and down. How far down does this graph go? Well, it only goes so far as 0. It does touch 0, so we'll use the square parenthesis to say 0 is included. How far up does the graph go? Well, on both sides, it goes up forever. That is, it goes up to infinity. Nothing in touches infinity, of course, so we'll use the round parenthesis here. Example 5. Here we look at a couple different symbols. We have the filled in circle and the empty circle. This filled in circle means it does touch this point, whereas this empty circle means it gets close to, but not touching that exact point. So when we talk about the domain, we're talking about left to right. I can see this graph goes to -2. But that open circle says it does not touch the -2, so we'll use a round parenthesis at -2. That's how far left the graph goes. How far right does the graph go? We can see that the graph goes all the way to the value 4, which it does touch. Range, how far down, how far up? We can see that this graph goes down as far as 0. This side, it goes up to 4, which it doesn't touch. But because this side goes up past 4 and goes all the way to 16, again, we're only looking for a minimum and a maximum. It does go all the way to 16, which it touches. Our range is 0 to 16. Example 6 gives us a function and asks us for a domain and range. Hopefully by now you can determine that this is a linear function. It has x to the 1 power. It may have a multiplier. It may have something added or subtracted to the end, but this is no doubt a straight line. Remember, a domain is anything x can be. So when I say, what could x be in this problem? What could you plug in for x? Hopefully you'd understand that our domain, what we could plug in for x, is anything from negative infinity to positive infinity. Obviously, we couldn't plug in infinity because we don't know how to do math, but with the infinity symbol, but anything up to those values. So what values will we get out the other side? Where does a line go as far as up and down? Hopefully, again, you see that we could get anything. Our range is negative infinity to infinity. So just a quick summary about interval and the set notation we saw in this. If we were dealing with these square brackets, 2 to 5, saying is x can be anything between 2 and 5, including 2 and 5, and we have those equal signs there. With the round brackets, what we're saying is x could be anything between 2 and 5 without the equal signs, non-included. And finally, this just means x is 2 and x is 5, nothing in between. Hope this helps. Thanks for watching.